the LNUG website and how we got it working offline. If you want to find me on Git, or if on GitHub, or if you want to find me on Twitter, it's at Simon McManus. And the LNUG website can be found at https://lnug.org. How many people have used the LNUG website before? That's good. We've got a few users. That's good to see. How many used it this month to find out about this event? A few. So we've got some users. The work's not going to waste. That's good to know. So just to cover a few of the basics around how the LNUG website works to start off with. In fact, what I'll do before that is I'll show you the LNUG website, just for those that haven't seen it before. So it's quite a simple site, static. Oh, I can move that if you want. We're not actually sharing the screen on Toolkit, you must close it. Oh dear. Right, we'll just pretend that didn't happen. Okay, so here's the website. Quite simple, we've got the next event date, the venue for the next event, link to the free tickets, map on the background, and the link of the list of talks that are happening at this event. Now those talks get managed through GitHub. So we've got a repo, and it's not, yeah, it is this one. LNUG/speakers. And if you want to submit a talk, you create an issue on here. There's a template and things like that. When you submit the issue, someone from the LNUG team will be in contact with you, talk about the idea, try and help you improve it, things like that. But after a little while, it will become accepted and scheduled, and it will get this. We've got these labels and tags. So when it's accepted and scheduled, and it's got a date that it's going to be that you've agreed to do the talk on, that will get pulled into the website from there. So that's just to cover where the data comes from, really. When I first started doing the LNUG website, there was various different markdown files all over the place, and we kind of wanted to bring them all together so they were sitting in a website. So one thing it does is it fetches various different markdown files and brings them into the site. It used to do a lot more. It's only doing 2 now. So the contact page, for example, is in a separate repo, and that just means people can make pull requests to that as and when they need to. So it's just aggregating the content, essentially. In terms of the actual site, it probably gets updated a couple of times a month. Where this becomes interesting is when you think about cache invalidation and the fact that you want to invalidate the cache quite often. But we'll talk about that as we go on. I wanted it to be mobile friendly and fast, just performant, as everything we build should be performant and fast. There's no reason not to make it that way. Slightly selfishly, I wanted it to be reusable. So the things that I'm doing for the LNUG site, I also wanted to use them on the enhancedconf.com site and on my own personal simonmcmanus.com site and some other sites that I've been thinking about doing. So there was a reusable element that I wanted to bring in there. And this last one's mostly a preference, but it kind of falls under the performance stuff as well. So always try and do things at build time. You can do it at build time, you can do it at runtime, or you can do it in the browser. If you can do it at build time, you do it once, and it's the quickest way because you're generating static files. You don't have to do anything at runtime. It's just static files you're serving. And then in the browser, you're not giving any extra work. So wherever possible, trying to do things at build time. We are doing client-side rendering. There is things happening client-side as well, but we always try and put all the work at build time. So if you want to have a look at the website, if you want to run it locally, if you want to try and make changes to it, just need to clone the repository, cd into the folder. We've got a build command. So it's a static site. It's currently hosted on GitHub Pages. The build command, what that does is it takes all the source, which is in the root of the directory, and puts it into a docs folder. And GitHub Pages serves it from there. The thing that I don't like about the current setup is that you're putting your source code into GitHub, but you're also putting what's generated from that source code. So the generated output is also getting committed to Git. This is one of the main things that makes me tempted to move off GitHub Pages and use something like Netlify, because you can run the build command in the CI effectively. So you just push the source, the GitHub hooks will pick up that, run the build, and then the site becomes live. So you're never committing the generated output with a Netlify setup. But we're not doing that yet. That's something I'd like to do in the future. Once you run the build command, you need to run start. So this is just a local development environment. It's not really for production, as it say. It's using GitHub Pages for that. We've got a watch command as well, which will just tell you if anything's changing. As a general rule, when I look at any new node project, I try and look at the package.json file. It's a nice place to understand what you can see the dependencies for one, but the script object is a nice way to see what functions you've got available, what commands you have that you can use. So I'm not going to talk through all of them now. You can go and have a look at them yourself if you're interested. If there's any command you want to know more about, you can look at the JavaScript code and you can see how it works. But the point here is if you're wondering how something works, this is a really good starting point. So if you want to see how the service worker works, you can see there's a command there. If you want to see how we generate the maps, there's a generate maps command. Interesting enough, I made it so that it's completely configurable where the venue is. So that map can change to any place. It just points at files which have got a long and latitude. Ever since I made that functionality, we've been in this one venue, so I've never got to use it. So I'm kind of hoping that we change venue at some point, just so it gets used. But yeah, we've got photos, we've got a gallery on there as well, but I'll let you have a look at that in your own time. The other useful thing to know here is, if you want to know what scripts are available and you don't want to look at the package.json file, you can just type npm run. This applies to any file with a package.json file in there, any folder, sorry. You type npm run, it will list the scripts that you've got available to you. Okay. So the very first talk that I did at LNUG, I checked the date today, it was 2012. So it was a little while ago. It was about syslate. So at the time, I was a client-side developer. I was working on the Volkswagen car configurator. Just to give it in perspective of things, we had Backbone then, but it was quite a new thing. So we were building our own custom MVC framework from scratch, effectively, at the time. And we were doing some nice patterns at the time. jQuery was the thing. You had jQuery in your apps at the time. And using the Sizzle selector engine, we were doing some interesting patterns client-side. None of this was server-side. It was Java on the back end. It was just client-side. And as I was experimenting with Node, I wanted to see if we could take those same patterns and use them server-side. And what I ended up with was this. So again, this is all happening just server-side. You've got a render function. You pass it some markup and an object. In this particular object, we're saying find a h2, update the inner HTML with this string, which is syslate example. And then this example, find a div, and then change the class name to have bacon. So the output you can see here. So it was quite simple, but it was a nice experiment. One of the nice things was when I turned up to do my talk, Andrew Nesbitt had actually rewritten the LNUG site using syslate, so it was already using it. That was at runtime, so at runtime it was doing the rendering. Now, I was keen to carry on with this and try and make it do a little bit more, try and work out how it might work on the client side and bring it over to do that. But when I started looking at doing it in sites, I realized I needed a little bit more structure than just templating, passing an object into things. And I looked at the things that across all the sites that I've worked on, the common things. There's some pretty common patterns across all of them. Now, I don't know if you realize, I've actually been showing you this in the LNUG website. On the previous slides, I've been hiding the header and footer and things, but this is just the LNUG website we're looking at the site in at the moment. And so what I wanted to show you here was how the layout works. So every single page has exactly the same layout. It's the header and the footer. Some sites have got more of a visual and obvious header and footer. Some of them, they're less visible. Some of them have just got meta crap and stuff like that in there. But all sites have got this same common thing. So in the root of the project, let's go in here. So we've got this pages folder. And in there, there's a layout.html. This is the bit which is shared across every single page on the site. And again, it can be kind of anything in here. The interesting bit is this container. So there's a div with an ID of container in there, and that's where the actual page content goes. That's where we're going to insert the page. So if we just go back to that example, actually we look here first. So in the pages folder, we've also got a speak folder, and then a speak.html file, and that's just what's going to sit inside that container. So if we just go back to here, what we're saying is take that page speak, add it into the container in the layout, and that gives us a pretty generic page, but then we want to do a little bit more. So that's when syslate comes into things. So we can also provide this spec, and again, we're going to update using the selectors. So find a nav item, a link with a class of speak, and give it the active class name. And then on the title, set the title to speak at LNUG. So now, I'm going to show you going onto that page. What you're going to see is the client-side rendering. Bear in mind, we're just talking about server-side rendering at the moment, so generating that markup on the server side. But as you see here, the active class means that that's got the slightly subdued state. The content's there and the title's been updated. Let's go back to the slides. Okay, so that's a very generic example. Now I'm going to show you the actual spec file for the LNUG website. So in the same way that the package.json file provides a nice starting point where you can look at how an application fits together and what scripts you've got available to it, the idea of the spec file is the same. It tells you how the application is going to fit together, and it's got your routing in there, it's got all the components and the pages, so you can see the basic structure to it. At the top, we're just defining some options. That's the docs folder that I mentioned there earlier. Worth noting here, there's two different arrays here. The first one is files that we want available on the app cache. The second is just files that we want available to everything. So we use these to load up the service worker so they're available offline, but we also use this list to copy them into the docs folder. The thinking there is that if we copy them into the docs folder, it won't work online or offline. By using this as a single source of truth, we know that it's always going to work, because it's very easy to make it so that it will work online and you don't notice it's broken offline. But making this always the source of truth makes it a little bit harder to do that. And then we come down to the actual root, so index.html, then the page is the home page, update the title. I don't know what that's doing, that doesn't really need to be in there, there's no bouncing in. And then here's an example of a component, so the ticket that we see there, we're doing various different things to get the venue. We can look at that code again, and then setting the link, and then the speakers here. On this component up here, it's just an object, so we get one ticket. On the speakers, the speaker selector method is actually returning an array, so it clones that object multiple times. So if you give it 3 items in the array, it creates 3 lists of speakers. Again, I'm not going to go into too much detail in here, but this is what makes up the site. If you want to see how a page works, you can go in here and have a look at it. If you want to add one, you add that page here, and this is used in various different places in the site, and hopefully I'll be able to explain where. Okay. So up to this point, we've got just static HTML files. We're just generating static HTML files at build time, completely plain HTML. But there is a client side to it as well. So I've put here this as a reminder, a classy router. It's not really a classy router. It does things with data attributes as opposed to classes. But what I wanted to do here is make it so you could, through CSS and things like that, you could address these pages and these routes if you wanted to. So at the very top level, against the HTML attribute, what we're doing is we're setting data speclate page to home, which is the page that we're using, and we're also setting the URL. The reason being that you could use a page across multiple URLs. But it lets us put this information into the HTML, and we can do quite powerful things with CSS, then addressing pages and various different things like that. The other thing it does as well is adds a nice loading class while it's going fetching data. Yeah, so let's look at some of the client-side code now that actually makes the client-side stuff fit together. Okay, so another thing I'm not too keen on is we actually compile index into all the client-side stuff sits in the client-side folder. When we build it into this folder as index compiled, and then it gets copied into docs as part of a separate thing. It's not ideal, but okay, so this is in no way perfect code, and it's kind of been knocked together. Adam did ask me to draw attention to things that need doing and issues where you can help out, so this is a really good example of one. At some point, the analytics code just stopped working, and the way that we fixed it was we just copied and pasted this block of code up to the top of the file. It's really ugly, it shouldn't be there. It can either just go into an internal require, or it could be come from an external required module. All we need is the analytics to work and it not to look quite so ugly. So if anyone wants a nice contribution opportunity, that's a good one. So first of all, we load the router. Speclates are the kind of what I've been calling the tools that I built around this spec format. We load app cache nanny. So we're loading app cache nanny for every single user. And again, not many people actually make use of app cache nanny. We'll talk about the different times in which we load the different ones shortly. But then we get into the router. So we've got this before event. Before you load a new page, we just look for a nav with a active, and we remove the class active. So that's what means that you don't have multiple pages. Because bear in mind, we're doing the routing client side now. Server side, it's been rendered with or without the active class. But if we do it client side, we're not changing the header and footer. The header and footer never gets re-rendered because it's already been rendered once, and all we're changing is the container div. So we use this just to remove the class, and then after we've finished changing the page, we need to scroll to the top, because if you imagine the header and the footer haven't changed, all you've done is change the content here. Part of the expectation is you'll be at the top of the page that you've loaded. So we need to force a scroll to the top of the page there. We also have some error handling. This is where it gets a bit more interesting for the offline stuff. So if service worker is available, we try and load the service worker. We register this service worker file. We catch the errors. We don't do much if there is. But if they haven't got service worker available, we start app cache nanny. So who here is familiar with the difference between application cache and service workers and the different bits? Okay, a few of you. All right, I'm just going to cover this last bit and we'll go on to talk about those slightly. So at the end there, for every single person, we do an on-update ready location reload. Again, we're loading the app cache nanny code for people with service workers, even though we don't need to. So we're trying to support both application cache and service workers, but that comes at a cost, the fact that we're increasing the page load times just to support both of them because there's more code that we need to load up. Okay, covered those. So the application cache is quite a simple mechanism for making things work offline. You essentially need to point to a manifest.app cache file. So this is the file that we use for the LNUG website. This actually has the idea of components and it has the idea of pages. At first, it was just the complete static markup was being saved in the app cache. This can do the client-side rendering with application cache as well. But it's pretty simple. We basically say all these files we want available offline. At the bottom there's a hash, a version number, whatever you want to call it. And that's what we use to bust the cache. So if we want to, if any of those things have changed and we need you to download them again, we can change that version number. Now, that does work, but it's not ideal. So a lot of the site doesn't change at all. Where the CSS, the JavaScript, the pages, the components, they very rarely change. The only thing that really changes is, well, the venue doesn't change either, we've established that. The speakers, the who's speaking and what they're speaking about, that's the thing which changes. So to invalidate all of these files, invalidate the entire cache just for that small bit of information is very inefficient. It's not very respectful of users' data. I mean, bear in mind you're doing it on a mobile phone, on a data plan, it can cost you every time you invalidate this cache. So we want to try and minimize that. One of the other disadvantages of app cache is just that it doesn't necessarily give you the updated page straight away. So imagine we load up the site and we're loading it from the cache. And in the background it says, oh, okay, there's a new version available. It goes and downloads that version. It finishes downloading that version and nothing happens. You're still looking at the old version of the site. So you're kind of constantly in this world where you're looking at the previous cached version and never looking at the latest version from the server. So that's kind of where app cache nanny comes in and helps us with the application cache. As you saw at the bottom of, have we still got it open? Oh, I'm not going to try that. As we saw at the bottom of client-side JS, it does that update. So for a long time, the experience on the LNUG website, it would load something from the cache. What you would be seeing was the out-of-date information from the cache. In the background, it would update that cache. App cache nanny would fire an update event and we'd reload the page. So for a long time, you kind of saw outdated data, and a second later, you'd see this month, the latest data. It provided a better experience offline, but the online experience still wasn't very good. Service workers allow us to do things slightly differently. This is not a talk that's going to go into detail about service workers. There's a whole family of different functions that you can use that come together to really give you the performance and the power of service workers. But for the time being, I'll describe it as this. You have a fetch method. So imagine just when you make HTTP requests in the browser, you use a fetch function. There's a function that you use called fetch. If you use that to make fetch your requests, you can use service workers to intercept those fetch requests. So instead of going straight out to the network, you can write JavaScript which decides what to do. You can have different strategies. So you can say, go to the network first, and if it's not there, then go to the cache. You can say, go to the cache first and then go to the network. There's lots of different strategies that you can build up. And you can have different strategies for different types of files. So you can say, for this type of file, go to the network first, whereas this type of file, go to the cache first. So yeah, what we end up with is different caching strategies. So, for the LNUG website, let's talk about the caching strategies that we've got in place. So, there's this architectural model that you might call it, I'm not sure. It's a Google term, the application shell, as a way of building progressive web apps. The idea is that every application's got this layout that we were using anyway, coincidentally. It's the header, the footer, the stuff that's always there, the stuff that never really changes that much. And that stuff, it doesn't change, right? So why would you go to the network to get it? So the idea is that as soon as the service, any request going to something via the service worker that's just a route, just serve them the application shell straight away. An empty app shell, but that gives the user instant feedback that they're A, on the right site. If they've gone to the wrong page, they've got access to the nav, so they can still navigate to change things. And it's almost a perceived performance thing, but it's getting stuff to the user as quickly as possible so that they can start interacting. So we use an application shell model on this. Every single route that was listed in that spec, the layout HTML file is the thing that gets served straight away. Once that layout kicks in, it's empty. The container's empty at that point. The router kicks in, looks at the route, sees what spec it's got to try and get. Now, earlier I showed you the specs being exported. So it was a JavaScript file. We could use JavaScript functions. We could generate the content quite easily. You remember what I said about having a preference for build time, execution to runtime or anything else? At build time, we take that spec and we create a file which is just the minimal amount of data that we need to render the page. So in this case, we're saying the page is the home page, and then the spec. This is all the things you saw earlier, except that you've got the strings. There's no JavaScript to execute here. You've just got the raw data, and then you've got the speakers, and then there's the list of speakers and what they're going to talk about. So this is the only single request which goes out network first. We show you the app shell. We go and request this straight away. If it fails, we go back to the cache. It's network first. We've still got the cache version there, but if we can get it from the network, we'll get it from the network. So what that means is we're always showing you the very latest version. It's always coming from the server if it can. But if you're offline, we can still provide a fully functioning experience because you've got the cache version. These slides have also got a spec, but I don't think we need to see that. So one of the things I was trying to make a bit clearer is just how cache invalidation works on the LNUG website, because it's not immediately clear and it could be improved. So as we saw there, anything in the spec, you don't need to do anything clever to update it. It's always going to try and get that from the network. So if you're making changes to the list of speakers, if you're making changes to the venue or anything like that, you can just push it, and those changes will be consumed on the front end. Other things, so pages, component, CSS files, JavaScript files, potentially do need you to bump the service worker. So I just wanted to show you, we've got some. So in the client directory, as I say, this is where all the client-side code is kept. There's a service worker JS file, and all we've got is a version number there. Now, that version number is kind of pointless and irrelevant. All it actually does is see if this file was changed. So you could add a bit of white space at the bottom, and it would effectively bump the version number. But we keep it in there just so you can see that your intention is to bump the version number. Things we're generally developing with service workers. That's wrong. That's meant to say test with Chrome Canary. Don't test without Chrome Canary. That will make your life more difficult. So yeah, test with Chrome Canary. There's just some nice development tools in there. Understand your tools. Look at the application tab. See what things you've got in there. There's some nice ways of. It's still not perfect. Developing with service workers is quite hard. Saw someone tweet saying with single-page applications, we broke the back button. With service workers, we broke the refresh button. And it's quite often the case. It can be really hard to see your content, the updated content coming through. But yeah, use Chrome Canary. Use one tab at a time because the service worker could be in the other tab as well. Incognito mode's your friend to make sure that you're not using an existing service worker. We've created a ticket, 147, which is basically to disable the service worker entirely on local development. If anyone's done this already, I'd be interested to hear how you've done it. I've got a few ideas, but I'm not quite sure how it's going to work. So there's an interesting job there if anyone wants to do some investigation. There's a nice tool called Lighthouse. No, I don't have it there. but it can work in, basically, I think it's from Google. It gives you a score about, it's got various factors it considers that make a good progressive web app, and it gives you a score on that. So it comes down to a performance a lot of the time. How fast can you load? Are you responsive? Do you do progressive enhancement? All these different things. At one point we had 100% on Lighthouse. That's slowly gone down, but it's good to check tools like that to see what score we're getting and that we can provide a good experience to the widest possible audience. So, hopefully for that little whirlwind, some of that stuff's made sense. I'd like to think that there's some opportunities there where if you're interested in getting involved in the LNUG website, there's things that you can do. Just to go over a few of those, 143, move Google Analytics code out of the client.js. That was the one we saw. Hopefully it shouldn't be too tricky. 103, show multiple events on the homepage. At the moment, we only ever show 1 month, but there's no reason it shouldn't show the next month or the month after that, just so you know what events are coming up and you can put them in your calendar. 146, set up speed tracker on LNUG website. There's an open source bit of software called Speed Curve. And what that does is it monitors over time what the performance of your site does. So it's looking at first render, all the key metrics in both actual performance and perceived performance. It kind of monitors them over time. It also does the Lighthouse score that we mentioned earlier. So it'd be nice to have something like that running on a regular basis so we can see when we introduce performance issues onto the site. Local dev mode that disables service workers, that one we've already mentioned. 149, columns adjusted 2 or 3 talks. I can show you what this bug is actually. So we're kind of indecisive about whether we're going to have 2 talks a month or 3. And at the moment, I'm changing the CSS every single time, just to facilitate that. And yeah, if we go to the home page, you'll see. So this is what happens when it's set to, the CSS is set to 2, but you just throw 3 columns at it. So like, for someone that knows CSS, this is a really small thing to change. I kind of know CSS, but I try and avoid it. Oh look, this is my map. So this is what happens when we don't know what the venue is going to be. So this is just a big zoom out on London. This is the unknown one. And look, we can, it's actually slightly nicer this one when it shrinks down. Apparently I can't shrink it down. Oh, there we go. And you get a slightly nicer view of London on the responsive. A smaller version. I think that's mostly it. Let's just check. If anyone's interested, I can show you how this presentation got put together using the website, but I don't think it's that interesting. Oh, and the other one's handling lightning talks. We haven't got a proper mechanism for handling lightning talks yet. Adam usually just submits a talk himself and he manually copy and pastes it. There's absolutely no reason we couldn't just add a label or a tag that says lightning talk, and then that gets brought into one particular column. But I haven't created the ticket, but if anyone's interested, give me a shout. As with any of this stuff, really, if there's anything you're interested in, if there's something you're wondering how it works, please feel free to reach out to me. I'm not always here, but I'm always available on the internet at simonmcmanus.com. My email address is mcmanus.simon@gmail.com if you have any questions. And even if you don't want to contribute, even if you're just using it and you notice that there's a problem on the website, just let us know, create an issue. It's nice to know that people are using the website, and if there's problems, we like to get them fixed. So I think that's all.